In this video, we will discuss the calculation of the cross product between any two vectors. It is often desirable in physics to multiply two vectors together such that they create a new vector. This is known as the vector product or cross product. To perform this operation, imagine the vectors starting from the same point. Then, project these vectors across each other so they form a parallelogram. The area formed by this parallelogram is equal to the magnitude of the cross product of the two vectors. However, cross products return vectors, so to determine the direction of the resultant vector, use the right-hand rule. Using your right hand, point in the direction of the first vector, and twist your wrist so that you can curl your fingers toward the second vector. If you stick your thumb up, it will point in the direction of the resultant vector. In this case, vector A points upward, vector B points to the right. So if you point upward and twist your wrist so you can curl your fingers toward the right, your thumb should be able to point in the direction of the resultant, in this case, into your screen. Another way to do this is to look at the smallest angle between the two vectors. If it is a clockwise rotation, the resultant vector is pointing into the page. If it is a counterclockwise rotation, the resultant vector is pointing out of the page. Notice then that B cross A is not the same as A cross B. The magnitude of the resultant will stay the same, but the direction will reverse. You can verify this using the right-hand rule. This time, point in the direction of the first vector B, which is to the right. Twist your wrist so your palm is facing the direction of the second vector, A, which is upward. If you stick your thumb out, it should be pointing out of the screen. If the vectors are not perpendicular to each other, the procedure will still work. The area enclosed by the parallelogram that the two vectors make is equal to the magnitude of the cross product. The direction is determined by using the right-hand rule. The calculation of the area of a parallelogram is simple and easier to see if we rotate our parallelogram. Notice the area is simply the sum of two triangles and a rectangle. Simple algebra will yield the area of a parallelogram as base times height. The height of a parallelogram can be written as one of the vectors multiplied by the sine of the angle between the two, so the magnitude of the cross product is simply the magnitudes of the two vectors multiplied together and by the sine of the angle between them. To determine the direction of the cross product, use the right-hand rule. Let's try an example. Here are two vectors represented in unit vector notation. I can use tangents to determine the angle between them, and then Pythagorean's theorem to determine their magnitudes. Typing this into a simple office calculator gave me an answer of 17.997. In fact, the answer should be exactly 18. The error comes mostly from estimating the tangent values. The direction of this vector is determined by the right-hand rule, which tells us the direction is outward from the screen. Using conventional axes, outward is the positive k-hat direction. There is another way to calculate cross products if you know the components of the vectors involved. Arrange the components of the vectors into a square matrix like this, with the top row being the unit vectors by themselves. The cross product is equal to the determinant of this matrix. A determinant is calculated by multiplying elements in a diagonal row and adding and subtracting these rows. The first diagonal is the main diagonal of the matrix from top left to bottom right, which is A sub j times B sub k in the i-hat direction. The second diagonal starts from the next column over on the top row and wraps around to the lower left corner, so we add A sub k times B sub I in the j-hat direction. The third diagonal starts the next row over and wraps around again, giving A sub I times B sub j in the k-hat direction. We then subtract the diagonals in the opposite direction. In the k-hat direction, we subtract A sub j times B sub I. In the j-hat direction, we subtract A sub I times B sub k. And finally, in the i-hat direction, we subtract A sub k times B sub j. This will yield the cross product. Let's throw in our numbers to see it work. In this case, because our vectors have no k-hat components, we plug in 0 for A sub k and B sub k. Therefore, everything with an A sub k or B sub k will collapse to 0, leaving us with a component exclusively in the k-hat direction. Plugging in for the variables yields 20 minus 2, so our cross product must be equal to 18 in the positive k-hat direction, exactly as we determined previously. Now we have two methods of calculating the cross product between any two vectors: multiplying their magnitudes by the sine of the angle between them and then using the right-hand rule, or by calculating the determinant of a matrix.